Empirical and molecular formulas. So the difference between an empirical formula is that the empirical is the reduced form, so lowest whole number ratio, and a molecular formula is how it actually exists. So we're going to go through the steps for finding empirical and molecular formulas. The first step when you are finding an empirical formula is to look at what the elements are in your compound. So for example, in this one, we have 3 elements in our compound. The compound is composed of 77.3 grams of silver, 7.4 grams of phosphorus, and 15.3 grams of oxygen. What is the empirical formula? So we are going to...
Please stop by the VPO. Coach Fernandez, if you can please stop by the VPO.
Write down our grams for each of the elements given in the compound. Now we cannot compare elements in grams. When we are comparing different substances, it must be in moles. So our second step is to convert these grams to moles. And whenever we're converting grams to moles, we use our molar mass. So we're going to look up our molar mass on the periodic table. So in 1 mole of silver, there is 107.868 grams. So that's from the periodic table. Same for phosphorus. I look it up. 1 mole of phosphorus, there is 30.974 grams. And for 1 mole of oxygen, it's 15.999. All right, we do that math and we get our moles. So this is how many moles of silver we've got when we do that math. This is how many moles of phosphorus, and this is how many moles of oxygen. Our third step to finding our empirical formula is to get the lowest whole number ratio. So we are going to choose which mole amount is the smallest and divide all these numbers by that smallest mole amount. So the smallest number is the 0.24. So we're going to divide all the numbers by that 0.24. All right, so once we get that we have a 3, a 1, and a 4. These are now our subscripts, our ratios. So we can write our empirical formula. For silver, there is 3 of them. For phosphorus, there is 1. And for oxygen, there is 4. Empirical formulas. Okay, let's talk about molecular formulas. The difference is that molecular formula is how it exists in nature. Okay, so the problem that we're given here is a compound is analyzed and found to have the empirical formula of CH2O, and the molar mass of the compound is 153 grams per mole. What is the compound's molecular formula? The steps for finding molecular formula is 1, you need to have the empirical formula. So if that's given to you, you are ready to start finding your molecular formula. But if it is not, then you have to do the steps from the previous example to get the empirical first. So the first step, once we have the empirical formula, is to get the molar mass of the empirical formula. So if our empirical formula is CH2O, we need to find the molar mass of that. Well, we have 1 carbon. We have, oops, that should be a plus. Two hydrogens plus 1 oxygen. So we add that up and we get 30.026 grams per mole for the molar mass of the empirical formula. Next, what we have to do is molecular formula mass divided by empirical formula mass. So 153 divided by 30.026. It must be given to you in the problem, the molecular formula mass. When you divide, that gives you 5, which is what you are going to multiply each of the subscripts by from the empirical formula. So the molecular formula is 5 times larger than the empirical, so multiply that out. Your answer is C5H10O5. Last problem here, you're going to have to do all the steps because you are looking for the molecular formula, but you do not have an empirical formula to start with. So what you're going to do is you're going to find the empirical formula, use that to find the molecular formula. We have a sample of salmon-colored powder that has 0.70 grams of chromium, 0.65 grams of sulfur, and 1.25 grams of oxygen. So our first step is to write them down. Alright, so these are the 3 elements in our compound. So now, because we can't keep it in grams, we have to change it to moles. We divide by the molar mass for each of them. And again, you find molar mass on the periodic table. Okay, you calculate that to get the moles. Okay, so all of these numbers are moles. That one is messy. Okay, 0, 1, 1. All right, so once you have all the moles, the third and final step for finding the empirical formula is dividing them all by the smallest mole amount, which is the 0.013. When I do that, those numbers will be the subscripts. 1, 1.5, and 6. Now, you need to be careful. These are subscripts. Subscripts are whole numbers. Notice how we have 1.5 here when we divided moles by moles. You cannot leave this. You need to multiply to get this into a whole number. Well, there are 2 halves and a whole, so we're going to need to multiply it by 2. Whatever you do to this number, you must do to all of them because it is a ratio and we have to keep it. So you multiply times 2 because of the 0.5. And our subscripts for our empirical formula is chromium 2, sulfur 3O12. Now you may notice that this is actually Cr2 SO4 3 times. Either way, this is empirical formula. We still need to do some more to get our molecular formula. Alright, so now that we have our empirical formula, we're going to find our molecular formula. First thing you have to do is get the empirical formula's molar mass. So I'm going to get the molar mass for this right here. Again, that's from the periodic table. So when I add that all up, it is 392.178 grams per mole. So that is my empirical molecular formula mass. I must be given my molecular formula mass. In the problem, You divide those two to see how much bigger your molecular formula is than your empirical. Notice this time, hey, look, these numbers are the same. So when we divide them, so you're going to take the molecular on top, 392.2, divided by the empirical, 390.178. That ends up equaling 1 because the empirical formula and the molecular happen to be the same this time. So that is your answer.